This summer, I took part in Innovation Central Perth's summer internship program. This is a 12-week program led by Innovation Central, doing projects across a wide range of areas for various different companies. There was 13 projects in total and one intern for each project. My project was indoor stockpile tracking and estimation using photogrammetry. Photogrammetry is taking measurements from photos. In modern day, this is using a series of photos to create a 3D model or point cloud. There are various methods for capturing these photos. Some of the more common methods are using a drone to fly over, or using a handheld camera and walk around the pile. Sadly, neither of these methods work very well indoors, since a drone cannot get accurate GPS localization indoors, and only the front of the pile can be seen when walking around it. So, my project was to find different methods to try and capture these series of photos required for photogrammetry indoors. I had three main ideas to try and capture these photos required indoors. The first was an extended camera pole, the second a cable camera, and finally a static array of cameras. ICP at the time did not have any cable cameras or extended camera poles, so then I got designing. First off the bat was the extended camera pole. I needed something that could be easily packed up, but also get to quite a large length, approximately 4 to 5 meters. I satisfied this by having 4 lengths of aluminium pole 1.5 meters long that can be joined together securely by clips, but then I needed to hold a phone in the end. This is when I got to have some fun. I got to design and 3D print a camera mount to put on the end of the pole. This mount needed to be adjustable and swivel around so the camera can see the pile properly. The camera pole worked quite well, able to hold the camera at 4.5 meters length quite easily with only a 5 to 8 kilogram load. And as you can see, it also worked quite well as a selfie stick. The final and more enjoyable part of the internship was getting to fly drones. Since there was no cable cameras around, this was simulated using a drone flying in a single line. Once I had simulated the cable camera, I then used the drone to fly zigzag patterns over the piles. That way I had another data set to compare the cable camera to, and I also had some data I could use in another software, Stockpile reports. Once I collected all the data, it was time to get analyzing. This was done using Agisoft's Metashape software to analyze and compute the 3D point clouds. Some of these took up to a day to compute, and I spent an entire week collecting and analyzing all the data. From the analysis, I discovered that the cable camera was the best solution, especially when the camera was ran over the pile, because if it was off to the side, it tended to leave a hole in the point cloud on the other side of the pile, as can be seen in this photo. After I had collected and analysed all the data, I needed to complete the 3 deliverables, which included this podcast, a presentation, and a white paper. Overall, I enjoyed my time at my ICP summer internship. I learnt new things, got to try my hand at research, and got a good idea of what goes into design ideas and development. I would like to thank Innovation Central and Curtin University for funding this internship, CSBP for proposing the idea, and Jim Watts for running and organising the entire event.